Hello everyone, and welcome back to another video in CCNA series from Netmastery Zone channel. If you remember, in the last video from CCNA series, actually we just had some basic configuration in a router, the hostname, the enable secret and password, and we see different mode of the router: the user execution mode, the privilege mode, the global configuration mode, and then we have some other mode like interface mode or any other services like DHCP or NAT or something. Then in this video I'm going to speak a little bit about the Cisco switch. We are going to speak about first we do the basic configuration in the switch. Actually this basic configuration in the router and switch is same, just the host name and some enable secret or password. And then we will speak about the VLAN, what is the VLAN and why we are going to use the VLAN. And then we will speak about the switch port mode and this three type of the switch port mode that is available in the Cisco switch. Okay, let's start our network. Actually I just designed this network to show you guys. You can see that I have two switches here, from the switch from first floor and switch to the second floor, and they are very simple layer 2 switch, 2960 switch with 24 port. And then we have three different VLAN here: VLAN 10, VLAN 20 and VLAN 30 in first floor, and also the same number VLAN in the second floor. And then I just assigned some IP addresses for this three different VLAN. You can see that they are in this different class, different subnet of IP address. You can see that I just selected 10 for VLAN 10, 20 for VLAN 20 and 30 for VLAN 30, and also it should be the same in the other side. Okay, let's start our configuration here. For that, first let's go to the switch of first floor, and before everything let's have a look on the physical view of the switch. In this view you can see that, let me zoom in, and you can see that we have 24 port switch with 100 base T. It means that they are 100 megabit per second, and two uplink ports, and they are 1 gigabit, 1G. And also you can see that we have a power plug here to connect it to the power, and also one console cable that why we need this console cable here. And also in the power cable you can see it's not removable, it's connected to the switch and we cannot remove that. And if you mention here that we don't have any power button for the switch. If you remember that we had a power button in the router, we was able to turn on and turn off the router, but for the switch there is no power button, and when you just plug it to the power it will be turned on and start its functionality. Okay, the console cable here, as I said before, in the real switch we don't have any CLI connected to the switch, because switch doesn't have any monitor or something. Because of that we need to connect our switch to a PC with the console cable to do the configuration. But here, as we have this option CLI in the packet tracer, we are going to use that, and I don't want to bring any PC here for the configuration. Okay, let's first I said the basic configuration. Let's go to the enable mode, enable this switch to privilege mode, and in the privilege mode let's go to the configure terminal, the global configuration mode, and let's assign a host name first. Host name, this is the first floor. And now let's do some enable secret for this switch. Let's select Cisco 123. Okay, let's write this configuration. If you remember, we have to get out from this mode and then write the command copy running config to a startup config, and now our configuration is saved. Okay, let's go to switch 2 and do the same configuration for that. You can see the same switch and the same physical view. It's a 2960 switch, and let's go here. First enable that, then go to the configure terminal, and here let's assign a host name. This is the second floor, and here let me enable secret also. Cisco 123. Okay, now I need to get out from this mode to go to privilege mode and write this configuration, but I have another option here, and this is the do command. Actually, do command save our time to not go out from the global configuration mode and come back to that, and because of that we can use this do command. And if I just enter right here, you can see that the configuration building the configuration, and the configuration is okay. It means this do command also can we can use this do command in the global configuration mode to use the command from the privilege mode here. Okay, for example, if I just run the command do show running, you can see that this do show running is working here. But if I just write it show running, you can see that the interface just give me an error and said this input is invalid, and it doesn't detect the command. Okay, now we have some configuration, basic configuration in this two switch here. Let's have a look to the interfaces actually. Before interfaces, according to our presentation here, let's speak about the VLAN and what is the VLAN actually. VLAN is a stand for virtual LAN. Virtual LAN means that we can divide one switch to many different switches. For example, it has a 24 port. We can make it 24 VLAN here and add one port in every VLAN. It means when we just create a VLAN, for example here VLAN 10 and VLAN 20, if I just create a VLAN here in the switch, these two VLAN cannot communicate to each other because virtually they will separate it from each other. It means it looks like that these two PCs connected to one switch and these two PCs connected to another switch. Virtually is just divide this switch to do two different switch and connect this PC to that. In this network actually it's not much practical because when I separate this VLAN and this different VLAN, create this different VLAN, this different VLAN cannot communicate to each other. For example, if it's an organization and for example this one is IT, and this one is for example HR, and this one be the finance. In the real organization, of course, this three section, this three departments need to communicate with each other and share information between each other. But here in this network that I designed here, I just decided to, because I'm going to show you the purpose of VLAN and also the different interface mode, and because of that I just separate this from each other. But in the real organization, of course, they need to communicate to each other. Okay. Let's see the VLAN here actually in the switch, what VLAN it's available. I'm going to use the show command, show VLAN. You can see that by default I have VLAN 1 as a default VLAN, and all these interfaces from 01 to 024, the fast Ethernet, and this 2 gigabit Ethernet is in the VLAN default and VLAN 1. If you see the physical here, this is 24 port and this 2 ports. the gigabit ports. They are all in the VLAN default, and also there is some other VLAN from 1002 to 1005, and this VLANs actually they are the default VLAN for the every switch, and they use this different VLANs for the switch management, and we are not going to speak about this. Let them be. They are in the you will learn about that in the high level, but not here. Here for the security purpose, let's assume that I just bring a laptop from my home and just connect that to this switch, and because all these ports in this switch is connected to VLAN 1, and when I connect my PC here, my PC will automatically go to VLAN 1, and then I can access all this different PC here, and it may be some server here, and also I will be able to access that server. And for the security reason, it's not a good practice, because when someone brings a laptop or a computer from the home, we don't know what kind of viruses may be in that computer, and if it's connected to this, and it will share that virus to all this PC, and it will destroy all the network. And also if someone will be able to bring its laptop and connect it to this and copy the very sensitive information from this network, because it can easily connect it and be in the network and receive IP address, then it can go to one of this PC and just copy some sensitive information from this, especially from HR part and finance part. It's very important that they may have some important information, and they can easily copy that and take it with themselves. Because of that, we need to think about the security of this switch. Yes, we just put enable password, enable secret on that, and no one can access this switch. But the switch doesn't have anything. It just have some configuration. The main purpose of our security is to secure our network, to secure our other PC, and also our servers, our resources here. And because of that, we need to do some configuration here. By default, as I said, all these ports are in the VLAN 1 and in the VLAN default, and it's a good practice to remove all these ports from the VLAN 1 and put them in a VLAN that is not used at all. For example, let me create a VLAN here. For creating VLAN, we can go to the global configuration mode and then type VLAN. I'm going to create VLAN 999, and now this VLAN is created. Let me show you. Do show VLAN. Now you can see we have VLAN 999 here, and it doesn't have any name. We can give a name for that. For example, let's give a name for this VLAN here. Let's go to the VLAN again, VLAN 999, and then type name, and let me name it for example unused. Yes. Okay, now let's exit from that and do show VLAN. Now you can see we have a VLAN 999 and the name is unused. Okay, let's add all these ports in this VLAN, and for example, let's go to interface fast 0x1, and then for adding the VLAN, we have the command switch port access VLAN 999. It means this switch port have access to VLAN 999. Okay, let's go to fast 0x2, and then interface fast 0x2 switch port access VLAN 999, and now we have to repeat this command for all this 24 port and also for this 2, and it takes long time. Of course, if I have 10 switch and try to add all this, it's 240 ports, and I have to just write this command 240 times to add all this ports to this VLAN. But here we have some shortcut for that, and that is the interface range. We can select the range of interface and apply a command on that, and that command will be applied on all the switches. For example, interface range fast 0x1 to 24. This command actually selecting all the fast Ethernet from 0x1 to 24, and also we have some other ports that is not fast Ethernet, they are gigabit Ethernet. And then with the comma we can just separate this, and let's type here G 0 by 1 to 2, or we can write this 0 by G 0 by 2. Now if I just enter, you can see I'm in the range and all this interface is actually selected. Now any command that I write here will apply to all this interfaces. Let's have switch port access VLAN 999, and now do show VLAN. You can see we can use this do command everywhere in the global configuration mode and also in the interface mode. Okay, and you can see here now we have VLAN 999 on use, and all this port is now is in the VLAN 999, and there is no port in the VLAN 1. Okay, now let's do something else. Okay, we just changed the VLAN 999, but this port is still up, and if someone just connected laptop or a PC to this switch, it will go to VLAN 999, and the problem is same, and it will be have access to all this network. And because of that, let's just shut down these ports. Okay, you can see that all ports is down, and they are in the red, and now there is no port is up here, and if anyone just connect anything here, nothing will happen because this port is physically administratively down. Okay, we just turn off this port, but we need to open some of these ports because of this different devices, PCs that is connected to, and that is let me see which port that we are using here, and it's from fast 0 by 1, 0 by 2, 3, and so on. 3, then this is 4, this is 5, and this is 6. Let's go to the interface range. Interface range fast 0 by 1 to 6, and also we need to open these two ports, and they are gigabit 0 by 1 to 2, and no shutdown. Now this all port is up, but there is no port here is open here. Actually, if someone wants to connect any computer here, you need to communicate with the IT section and ask them to open a port for them, and then everything will be under your control, because you will ask them why you want this port to be open, what do you want to connect to this port, and then you can control the situation of the switch. Okay, now let's run another command here, do show run, and here you can see in the interfaces that this one, for example, interface 0 by 1 and switch port access VLAN 999 up to 6, and also the other switches, they are also in the VLAN 999 and they are shut down. Okay, now we just did some security in our network, but still our network is not ready, because here we have VLAN 10, VLAN 20, and VLAN 30, and we need to add these interfaces to its relevant VLAN. For that, let's go to interface fast 0 by 1 to 2, and then interface range, and let's have switch port access VLAN 10. Now these two ports is in the VLAN 10. You can see both of them become green, and they are trying to renegotiate, and I will speak about that later. What is this negotiation? And you can see that I didn't have VLAN 10 here, and I didn't create actually the VLAN 10, but when I just add this, it gave me the command that the VLAN is not exist, and then it just create the VLAN. If I do show VLAN, you can see that the VLAN 10 is created here, and this two port is in the VLAN 10. Let's go to VLAN 10 actually, VLAN 10, and let's give a name to that. And name, for example, this one is IT, and it's created. Okay, let's create a VLAN 20. VLAN 20, and let's name that to HR. And also let's create VLAN 30 and name it finance. Okay, do show VLAN. Now you can see we have VLAN 10, VLAN 20 and VLAN 30, and they have their own name. This VLAN has these two interfaces, but this other VLAN doesn't have any interface. Let's have this other interfaces to the relevant VLAN. For this VLAN HR, we have interface fast 0 by 3 and 4. Let's go to that interface range fast 0 by 3 to 4, and then switch port access VLAN 20 and interface range fast 0 by 5 to 6, and then switch port access VLAN 30. Now do show VLAN. Let's see again, and now you can see that all these ports are in its relevant VLAN and they are open, but the other ports, the unused ports, they are in the VLAN 999 and they are turned off, except these two. Let me remove this two from VLAN 999 and let me add them back to VLAN 1. I will speak about that later. You can see that I'm just receiving some messages, and these two messages because of these two interfaces here. I will speak about that later. Interface range gigabit 0 by 1 to 2, and then switch port access VLAN 1. Now these two messages will be removed. Okay, let's do write. Now I just write the configuration here, and this switch configuration is done. And let's go to floor 2 and in the second floor and try to configure do the same configuration here. Let's enable here and then Cisco 123 and configure terminal, and then let's create a VLAN 999, name it unused, then VLAN 10, name it IT, VLAN 20, name HR, and VLAN 30 and name it finance. Okay, let's see the VLAN here. Do show VLAN. You can see that we have all these VLANs, but there is no port assigned to this VLAN. Let's first add all these ports. Add the ports to its relevant VLAN. For example, interface range fast 0 by 1 to 2, and it's switch port access VLAN 10, and then we can just use the arrow command to go to the arrow key to go to this different command that we typed before, and we can just edit it here. For example, 3 to 4, it's switch port access VLAN 20, and then again arrow command 2 times, and now 5 to 6, and this switch port access VLAN 30. Now do show VLAN. Let's check. Okay, now we have this ports in the relevant VLAN, but the other ports are still in the VLAN 1 and VLAN default. Again, for security reason, let's remove all these ports up to 24 and add them to VLAN unused and turn them off. Interface range fast 0 by 7 to 24, and then switch port access VLAN 999, and then shut down. You can see that then change to state to administratively down. It means these ports are now turned off, and if we connect anything to them, nothing will happen. Do show VLAN, and now our configuration is done, but still we have these two ports in a VLAN 1, also in the other side is also in the VLAN 1, and we will speak about them later. Now we have the ports in the relevant VLAN and the unused port on VLAN 999, and they are turned off. Then we don't have any security issue here. Okay, now let's try to ping from one PC. For example, I'm going to ping from PC1 to PC2 and in the VLAN 10. Let's do that. Let's go to command and let's ping it. The IP address for that you can see here, 192.168.10. For PC1 is 100 and for PC2 is 101. You can see that I can ping 101. This is PC2. You can see the IP address here, and this is 101, and I can ping that. And let's try to ping from VLAN 10 to VLAN 10 here. No, let's try to ping to other VLAN. Of course we cannot ping because we are in the different range of IP address, and also they are in the separate VLAN. Even if I just change the IP address of this and try to ping from here to here, the ping will not be successful. Let's try that. For example, in PC3 I'm going to add that to range of the VLAN 10. It's 10 dot, for example, 105, and okay, now this PC has a IP address of 105.10.105, and if I try to ping it from PC1, it will not be successful because we just separate our ports with different VLANs, and the VLANs between the VLAN routing is not allowed, and we cannot ping from one VLAN to another VLAN. And there is I didn't read any report about VLAN leaking, for example, if someone tried to hack from one VLAN to another VLAN, and that is the in the part of the security. We are not going to speak about that now. Okay, and you can see that we cannot ping it, and let's get back here and change our IP address to its relevant VLAN. It's 20, and this is PC3. The IP address of that is 100. And okay, now if I try to ping from PC4, for example, to PC3, ping 192.168.20.100, you can see I can ping it. But here also we have the same VLAN here. For example, if I try to ping from PC7 to PC8, let me see the IP address of PC8. It's 102. 10.102. Let me try to ping it from PC7. Ping 192.168.10.102, and you can see I can ping from this side. But if I try to ping it from PC7 to PC1 here, the IP address is 100. You can see here the IP address is 100, and if I try to ping that, it will not be successful because these two ports is connected, of course, but these two ports are in the VLAN 1, and VLAN 1 doesn't transfer the traffic from any other VLAN. It's if anything in the VLAN 1, then we can transfer the traffic from that. Okay, let's configure our switches to add this one of these ports to VLAN 10, and then check our connectivity. Let's go to interface gigabit 0.1 and then switch port access VLAN 10. Now this port is in VLAN 10, and let's wait for that, and I'm going to show you the message that this message actually. When this port is come back, you can see it's now orange, and it's negotiating with the other side. And when it come back, you can see we will receive such a message. Actually, this message, yes, we just received the message. You can see it say the native VLAN mismatch discovered on gigabit this 10. It means it's VLAN 10, and in the other side, in the second floor, gigabit 0.1, and it's 1. It means this side is in VLAN 10 and other side is VLAN 1. And because of that, it just give me this message, and it say that the two sides are not in the same VLAN. It's a very common message actually when you try to configure and you just make a mistake with the two sides of the VLAN, you will receive such a message, and it's very informative actually. You can see the the gigabit 0 by 1 in the 10 and the gigabit 0 by 1 in the second floor switch, it's in VLAN 1. And because of that, it just give you this message, and also you will receive this message in the other side also. You can see in this switch it's VLAN 1, in the other switch in the first floor is in VLAN 10. Okay, let's add this interface gigabit 0 by 1 to switch port access VLAN 10. Okay, now both sides are in the VLAN 10, and this message will remove, and we will not receive any message like that again. And now we should be able to ping from PC7 to PC1 here. Let's try that. And also we have to wait for this port to come back. Now it's negotiating, and if I try to ping it 100, it's not successful, of course, because this port is orange. Let's wait to become green, and after that you can see when the port become green, now we are able to ping from one side to another side. Okay, now we can ping our VLAN 10 from this side to this side, from first floor to second floor, and now our VLAN 10 network is ready to use. But for others also, think about the VLAN 20. Now VLAN 20 needs to be communicated with VLAN 20 here, and we don't have any port here to VLAN 20. Let's have the other port, the gigabit 0 by 2 to VLAN 20. Interface gigabit 0 by 2 and switch port access VLAN 10, and let's do the same for the second floor. Interface gigabit 0 by 2 and then switch port access VLAN 20. Sorry, this one I just typed 10. Let me change that to 20. Okay, now both sides are in the VLAN 20 and they are negotiating, and now we should be able to ping from PC 3 to PC 10, for example. Let's ping it. 192.168.20 dot I believe the IP address of this is 103, and it's not because this port is not green now. Okay, now the port is green. Okay, we are now able to ping from one side to other side. Okay, this problem is also solved. But what about the VLAN 30? You can see that we have these two ports here, and now we need to actually add another port, but we don't have any gigabit port here. We only have 2 gigabit ports, and we should connect this to actually VLAN 30 with the fast Ethernet port. And assume that we have, for example, 20 VLAN here. Then we need to just have 20 ports here to connect this switches for every VLAN 1 port, and this is not very practical because all ports, 10 ports will goes to just communicating 2 switches, and our switch is only 24 ports. If 10 ports is used for this, and only 14 ports will left, and it's not practical. For example, if we have 20 VLAN here, then 20 ports will be used for transferring the information between 2 switches, and only 4 ports will left. And because of that, we have another type of the mode here for the switch. Okay, now let's speak about the different mode of the switch. As I said here, we have dynamic port, access port, and trunk port. By default, all these ports in the switch is a dynamic mode, and you saw that when I just, for example, disconnect this and connect it back to this. You can see it takes it become orange, and it means that it's actually negotiating. Negotiating means this switch, because it's in the dynamic mode, and this one also in the dynamic mode, and now they are trying to actually decide that what kind of the port mode they should select. and here, because both of them are in the same VLAN, they will decide to become access port. And you can see that now it's become green. And if I see this mode here, let me show you. For example, let me exit from this mode here, and let's go to with the Control Z, you can just get out from all the configuration and go to the privilege mode. Here, let me show command show interface gigabit 0x1. You can see in this command, it will show you some information about the very detailed information actually about the interface. You can see it's the state of that is up, the LAN protocol is up and it's connected, the hardware license, the address is actually the MAC address of that, and also the bandwidth. You can see it's 1000, and delay and so other information. But here we are looking for something like okay, let me see. Actually here it doesn't show any information about the mode of this switch, this port. Let me show interface fast 0.1, and yes, switch port. Okay, in this information you can see the name of the switch, and also switch port is enabled, and the mode is dynamic auto. It means that it's automatically search for the other side and will decide what what mode is in the other side, and then it will select himself as a for example an access mode or a trunk mode and so on. And other information that you can see here, the operation model, static access, trunking is administrative trunking encapsulation, and we'll speak about that also. Okay, and let's actually now we know about the dynamic mode. What is the dynamic mode? The dynamic mode, when we put a port in a dynamic mode, it will communicate with the other side and negotiate with the other side, and will select its type its mode according to the other side. If one side is access mode, it will be access, and if this side be the dynamic, it will be and of course if it's a dynamic and it's in the VLAN, then it's because it's in the VLAN, then it will select it as access mode, and when this side is a trunk, then it will select himself as a trunk. And here the access mode is what is the access mode? The access mode is when you just connect an endpoint to this switch. It means that this port is the access mode. When, for example, I just connect this PC to this switch, and this switch will communicate with the other side and see its endpoint, and then it will select himself as a access mode, and it will automatically configure as a access. And also let me see what other mode here. It's a trunk mode. The trunk mode, actually the main port that I'm going to speak about that. This trunk mode is designed to actually transfer the traffic from all VLANs from one side to another side. As we discussed before, if we add, for example, 20 VLAN here and wants to have one port for every VLAN between these two switches, then all our ports will be busy for just connecting one switch to other switch. And because of that, we have a trunk port. And actually what trunk port do, the trunk port in the one switch, for example, if this two port is configured as a trunk, this switch will when it try to send traffic to other side, first it just tag the packet. For example, packets come from the VLAN 10, it just tag it to VLAN 10 and send it to this switch, and the second switch receive that, first open the tag and see, okay, this traffic is for VLAN 10, and it will send it to VLAN 10, and if the tag is 20, it will send it to VLAN 20. In this case, actually our job will be very easy, because with one port actually we can connect 100 VLANs from one side to other side. Okay, let's configure this port as a trunk, and please mention that. And now in both sides they are in the dynamic mode, and if I just change one side to the trunk, the other side will automatically negotiate with this and become trunk. Let's do that in first floor. Let's go to configure terminal and interface range gigabit 0 by 1 to 2, and now switch port mode trunk. Now this two port is trunk, and you can see that this side now is trying to negotiate and select the mode. If I check the mode here, you can see show interface gigabit 0 by 1 switch port, and here in the mode you can see that the administrative mode is trunk, and now it's operating as a trunk here, and the encapsulation is .1q. What is .1q here? For the trunking purpose, we have two different standards. One is .1q and another one is ISL. And what is different between these two? The .1q is open standard, and it's become a standard in IEEE, I can say organization, and it has some specification. The .1q actually just sending traffic from, as I said, both of them tag the VLAN, but the header of this packet, for example, if we send that with the .1q, the header of that for .1q is 4-bit, but for the ISL is 30. For .1q is 4 byte, and for ISL is 30 byte. It means bigger than normal packet in .1q. And also the .1q, as I said, is open standard, and Cisco, the ISL is for Cisco, and Cisco actually developed that, and it's only working in the Cisco switches, and also some other specification they have. For example, .1q send the VLAN 1 without tag. If any information come here and it's from VLAN 1, it doesn't tag that and send it here, and this switch knows if it doesn't have a tag, it's belong to VLAN 1, and if it has a tag number for a 4-byte tag, then it will check that it's for which VLAN. And also some other different they have, and different with the number of VLAN that they can support, .1q instead of ISL, and so on. But here let's now we just configure that as a .1q, and you can see now the other side is green. This one is orange, and I will tell you why it's orange later. But let's go to switch 2, floor 2, and see the state of this port. This is fast gigabit interface, show interface gigabit 0 by 1 switch port, and here you can see that the mode is trunk, and also the encapsulation is .1q. And one thing more, this is the dynamic auto. It means that this is in the dynamic auto, and when it's negotiate with the other side, it just decide that to become trunk. And if you compare that with switch 1 here, first floor switch, and here you can see that this is the administrative mode is trunk. It means we just with the command forcefully change this mode as a trunk, and then operation mode of course as a trunk. But this one, the administrative mode, is dynamic auto, and the operation mode is trunk. It's just negotiate with the other side, and because this side was a trunk, it just decided to become trunk. and also the encapsulation and so on. Everything will be by default will be selected from the other side. Okay, you can see that access mode VLAN 10 IT and default VLAN, and we don't have any voice VLAN and so on. Okay, let's do something. Also, we have another command here for show interface trunk, and here you can see that we only see the ports that are configured as a trunk. You can see mode is on. Mode is on means that this trunk mode is on. It means this port is trunked by the force. And if I show it here, show interface trunk, you can see the mode here is auto. It means it's automatically selected to be trunk. And also the VLAN that is allowed in this is from VLAN 1 to 1005. It means all VLAN. Actually, we can select for this. If I go to interface trunk, for example, configure terminal, and let's go to interface gigabit 0x1, and then switch port trunk. Here we have a option to allowed which VLAN can actually transfer to this. For example, I can just stop one VLAN to transfer to this trunk. For example, I can say allow VLAN, and I can give a range of I can give a name, all, it means all VLAN, or I can remove some. For example, I'm going to remove for example VLAN 999. Now if I do show interface trunk, you can see that it's only from 1 to 998 and from 1000 to 1005. It's 999 between is not allowed in this port actually, but in the other port it's same. It's from 1 to 1005. It means all VLANs. But you see here that one of this port is now orange. And why this one is orange? We select these two ports to be trunk. It means that we have two connections between these two switch, and this port is now in the standby mode, but the spanning tree. We will speak about the spanning tree in the future video, but just for now, the spanning tree is to remove the loop from the switch. For example, if I just send a packet from VLAN 10 to VLAN 10 here, and I'm trying to ping, for example, 10.200. We don't have any computer with 200 IP address here in the VLAN 10, and if it comes from this port, and this switch see that there is no any source for 200 IP address, then it will send it back through this link. The switch is designed to never send back any packet from the interface that it received, but it can send it to from another interface. For example, this switch doesn't know if there is any switch here, and it may be another switch here, and it will connect it to this port, and because of that, this switch doesn't know the other side is also connected with the same switch, and it may become a very big loop here. This packet will send to this switch, and this switch is sent it back to this switch, and again, and this loop will be continue, and the boot switch will be down. Just in a second, they will be down, and they will not give any service. The good thing about the Cisco switches that they are supporting the spanning tree, but there is some dummy switches, and it's just a switch. It doesn't have any configuration. All the ports are in VLAN 1, and then you can connect all your computer to that, and they will communicate to each other. In this case, if you just use such a configuration, for example, connect two ports from one switch to other switch, and it makes a loop, infinitive loop actually, and boot switch will be down in just some seconds. Okay, and we will speak about this spanning tree later in the future video, but now you can see that we just configured this port as a trunk, and now we should be able to ping everything from this side to this side. To test that, let's ping from PC5 to PC12. Let me see the IP address here. It is 30.103, and let's go to this PC5 and try to ping it. ping 192.168.30.103. You can see that now I can ping from this PC to this PC, and I didn't actually configure any VLAN for any port here, because I just configured this port, these two ports as a trunk from one side, and the other side will also negotiate with this, and it's become a trunk. But the good practice is to change the boot side as a trunk, because again, the security purpose. And if someone just remove this port, for example, I'm going to remove this and then plug my computer here, because this is a dynamic, then it will negotiate with the PC and become access port. And actually it's not something that we want. And because of that, let's just go to interface range gigabit 0 by 1 to 2, and then switch port mode trunk, and let's switch port trunk allowed VLAN all. Let me give access to all VLAN to transfer through this VLAN. And one thing more that I should tell you here, if you saw, for example, if I go to this range, interface range gigabit 0 by 1 to 2, and switch port trunk, you see that we have allowed VLAN and another option here, that is the native VLAN. And what is the native VLAN? As I said, by default the VLAN 1 in the .1 queue is assumed as a native VLAN, and because of that it doesn't tag that as when it sends it to other switch, it doesn't give any tag to that. But we can select for example VLAN 10, native VLAN as a VLAN 10, and now native VLAN 10. Now our VLAN 10 is the VLAN 10 is a native VLAN, and now when it sends the traffic from VLAN 10 to this side, it doesn't tag that. But it's very important to do it in the boot side, because boot side should be aware about that. I just did it in the first, and you can see, and now I'm just receiving the again mismatch VLAN, because this side doesn't know that VLAN 10 is a native VLAN, and again it just tagged that with the 10, and if it's come here because it has a tag, it just trying to find the VLAN for that. And let me change that also in this side and enable, and then let's conf t interface gigabit 0 by 1 to 2 interface range, and switch port trunk native VLAN 10. If I just change the native VLAN 10, now this mismatch will be gone, because now this switch knows when it's sending any information in VLAN 10, it doesn't tag that, and this switch also know that VLAN 10 doesn't have any tag. And when it's come here and it doesn't have any tag, it knows it's for VLAN 10, and it will send it to VLAN 10 here. Okay, I think we have a lot of information here about the different switch port mode actually, and different VLAN. Let's just have a short review and finish our video. The first one, we just speak about the different VLAN, and we said that the VLAN is just create a virtual switch here, and it separate the ports from each other. Here for example we have these two ports in VLAN 10, and VLAN 10 cannot communicate with VLAN 20, and so on. And also we speak about the different type of the switch port. The first one was a dynamic. This is by default all ports are in dynamic mode, and if you connect the endpoint to that, and it will negotiate with that device and decide to become an access port or to become a trunk port. and here by default all of them as a dynamic, and when we connect this it becomes an access port, and when we just change here to trunk and this side was a dynamic, it just negotiate with that and configure himself as a trunk mode. Then we have a dynamic mode, access dynamic port, access port, and the trunk port. And also the trunk port is to transfer the information from all VLAN. For example, if we have 100 VLAN here, it can transfer that through one port, and we can configure that port as a trunk. And also the trunk port tag the VLAN number, and we have two standard for trunk port. It's .1Q and ISL. .1Q is an open standard from IEEE, and ISL is a Cisco protocol, and it's only available in the Cisco switches. But unfortunately, it's not available in this packet tracer, and we cannot check that here. But in other in the real switch, you can change the trunk port to ISL. And some difference between the ISL and to the .1Q. The .1Q send the native VLAN in the .1Q is VLAN 1, and it doesn't tag the native VLAN when it send it. We can change the native VLAN as we change it here in VLAN 10. Now VLAN 10 is a native VLAN, and if it send it to other side, it doesn't tag that to VLAN 10. And if we just change the native VLAN from one side, we need to do it in the other side also, because the other side should know that this VLAN is a native VLAN. And anything else about that? The .1Q and ISL, we said that the ISL the tag in ISL is 30 byte, but for the .1Q is 4 byte. It means that it's using the less bandwidth to make a frame for sending to other switch. And also the number of the VLANs that they supporting, they are different. For example, the .1Q is supporting 1024 VLAN, and the ISL support 4098 VLANs, and some other information, some other differences also available. But in the oral, even Cisco recommend to use the .1Q for the trunking, and that is the best trunking protocol. Okay, thank you for watching, and please subscribe us and follow us in the in NetMastery Zone to receive the future videos, and in the next video we'll continue our CCNA series. Thank you for watching, and see you in the next video.